In this video, we're going to look at even functions and y-axis symmetry, odd functions and symmetry with respect to the origin, and also x-axis symmetry. We'll start by looking at what are called even functions. A function is defined as even if opposite real values of x result in the same y value. In other words, we could say f of a equals f of negative a for any real value of a. A good example of this is f of x equal x squared, since when you put in opposite values of x, you get the same y value. And here's the graph of y equal x squared. As you can see, when x is 1, we get y equal 1. When x is negative 1, we also get y equal 1. When x is 2, we get y equal 4. When x is negative 2, we get y equal 4. And besides this property of giving the same y value, the graph will always have symmetry with respect to the y-axis. The left side will be a mirror image of the right side. Let's look at another example. We're going to plot the graph of y equal x to the fourth minus x squared. Then we're going to determine if this is an even function. And also note any symmetry of the graph. Well, to plot this graph, we have to find and plot all the intercepts. When x is 0, we get y equals 0. We have to also let y equal 0 and solve 0 equal x to the fourth minus x squared to find the x-intercepts. We factor that expression and we get 0 equal x squared times x plus 1 times x minus 1. We let each factor equal 0 by the zero product law, and we get x squared equals 0, x plus 1 equals 0, and x minus 1 equals 0. That gives us three solutions for x equals 0, x equal negative 1, and x equal 1. These are the values of x when y is 0. So the intercepts we have are 0, 0, negative 1, 0, and 1, 0. We plot these intercepts and find some more points to complete the graph. And when we find the additional points, we plot them and then draw the smooth curve through, and you get kind of a W-shaped curve. And if you notice from the points I've found, when x is 2, we get y is 12. When x is negative 2, we get y equal 12. When x is a half, we get y equal negative 3/16. When x is negative 1/2, we get negative 3/16. So the opposite x values are giving us the same y value, and this is because our formula is y equal x to the fourth minus x squared. All of the x terms are even powers. This graph is of an even function, and there is symmetry with respect to the y-axis. Now, what's good about noting when a function is even is you know that it's going to have the symmetry even before you graph it. So this can give you a lot of insight into the graph and the behavior of the function. A function is said to be odd if opposite real values of x result in opposite y values. In other words, f of a equals negative of f of negative a for any real value of a. We're going to graph y equal x cubed here, and then we're going to note the type of symmetry that we have. Well, when we plug in x values, 1 gives us 1, negative 1 gives us negative 1. When we plug in 2, we get 8, but negative 2 gives us negative 8. 1/2 gives us positive 1/8. Negative 1/2 gives us negative 1/8. So when we put in the opposite x value, we get the opposite y value. So this is an odd function, and now look at the symmetry. What you really have here is what's called symmetry with respect to the origin. This means that if you flip the graph upside down, you would get the same graph. And here I'll show you this effect. We take the graph, rotate it 180 degrees about the origin, and look, we get the same graph. That's the property of having symmetry with respect to the origin. And here's an example where we determine whether f of x equal x cubed minus 1 is odd or not. Well, the first thing we can do is look at its graph. If we have its graph available, we do have the graph, it's x cubed shifted down 1. Is there any way that we can rotate that about the origin and get the same graph? Well, the answer is no, we can't. Another way to tell if a function is odd is to plug in two opposite values. Plug in 2 and negative 2. In this case, we plug in 2 and we get f of 2 is 2 cubed minus 1, which is 7. And when we plug in negative 2, we get negative 2 cubed minus 1, and that equals negative 9. Since negative 9 is not opposite of 7, this function is not odd. And now let's take a look at x-axis symmetry. The graph of an equation will exhibit x-axis symmetry if opposite y values result in the same x value. Here's an example. We have x equal y squared, and its graph is shown below here. Here, when we let y equal 3 and negative 3, we get x equal 9. When we let y equal 2 and negative 2, we get x equal 4. We're getting the same x value for opposite y values, so this graph does have x-axis symmetry, and from the graph it's very clear that the graph is symmetric with respect to the x-axis. Now note that this type of symmetry never applies to y as a function of x, because by definition y is only a function of x if an x value results in only one y value.